We're going to go through this really quick because we got to get to notes and it's Thursday. We got a shorter day, okay? So remember, we're always going to label them x1, y1, x2, y2. Okay? And our formula that we're going to use is y2 minus y1 over x2 minus x1. So if we just plug in all these labeled points, we'll get 4 minus 6 over 8 minus 10, which is just negative 2 over negative 2, equal to 1. Right? A negative over a negative cancels out those negatives, and we get a positive 1 for our slope. x1, y1, x2, y2. 2 minus 3 over negative 1 minus 6. 2 minus 3 gives us negative 1. And then negative 1 minus 6 gives us what?
Negative 7.
Negative 7. That's right. Once again, a negative over a negative equals a positive. We get 1/7 for our slope. Okay, not 7. 1 over 7. All right, number 3, x1, y1, x2, y2. 4 minus 11 over 10 minus 8. What's 4 minus 11 going to give us? Thank you very much. Negative 7, right? And then 10 minus 8 is 2. Can we simplify negative 7 over 2 at all? No, we're good. That's our answer. Negative 7 over 2. All right, we got a lot of negative signs going on in our denominator for number 4. I'll move that up so you can see it. Can you need me to zoom in? Yeah, go ahead and go now before notes.
Student services.
So, 7 minus 12 equals what? 7 minus 12? No one got that?
Oh, negative 5.
Oh, there we go. Negative 5. Perfect. And then what about negative 5 minus negative 10? That's just plus
Positive
10.
5.
Negative 5 plus positive 10 is positive 5.
It's also equal to negative 1.
So we get a slope of negative 1. Make the necessary corrections if, for example, you put the x's on top and the y's on bottom. Just make a little note. You got to flip them around. Y on top. Okay? Just make little notes for yourself so you know when you're going back through your worksheets on a test. All right, number 5, we got 9 minus 3 over 3 minus 0. 6 over 3 is 2. Negative 9 minus negative 3 over 1 minus 5. Negative 9 plus 3 gives us negative 6. 1 minus 5 gives us negative 4. And what is this going to simplify to? Anyone get the simplified answer here?
3 over.
Yeah, Miguel?
3 over 2.
3 over 2. Positive or negative? Positive, that's right. A negative divided by a negative cancels out and you get a positive. Questions on the front? I'll leave this up so you can get it copied down real quick if you need to. All right. Anyone still writing? Yes, okay. Yes, Ella.
Oh, can I see number 3 and 4?
Yes, absolutely. Yes. What's that? Number 2, yeah, I'll move it up in just a second. I'll slow down on the back a little bit. Here's number 2 for you, sir. All good? All right, to the back we go. All right. X1, Y1, X2, Y2, negative 4 minus 2 over 5 minus 15. All right? Who's got negative 4 minus 2 for me? Noah?
Negative 6.
Negative 6, thank you very much. And 5 minus 15, what's that give us?
10.
Negative 10, that's right. Negative over negative cancels out. 6 over 10 reduces to 3 over 5. Thank you, sir. And our answer is positive. So something to keep in mind, there's a lot of things that will change your answer, right? If you accidentally add here instead of subtract, or if you add here instead of subtract, that's going to give you a wrong answer. If you plug them in backwards on the top, but right ways on the bottom, you're going to get a wrong answer. So this procedure is very, very structured so that every time we can follow it exactly how we need to get what we want. All right? Number 8, we got 3 minus 7 over 5 minus 3. Negative 4 over positive 2 gives us negative 2. And I'll leave that there for you to write. Questions on 7 and 8? Yes.
How long are notes going to take?
They're really short. We just have 2 quick things to talk about. All right. I'll try and leave that there. Okay, number 9, negative 3 minus 19 over positive 6 minus positive 8. Negative 3 minus 19. What is that? What's that going to be? Negative 3 minus 19?
Negative 22.
Negative 22
Quick math.
over 6 minus 8 gives us negative 2. Now I saw a couple people leave their answer just like that yesterday. There's 2 things we need to do in order to simplify this. Olamipo, what do we got to do? We're going to, one more time? That's right. We're going to divide negative 22 by negative 2. Negative 22 is just 11 times 2. I'm going to move this down. If we broke up 22 into 11 times 2, we can see, hey, we got a pair of 2's that we can cancel out, right? And we've got a pair of negatives we can cancel out as well, leaving us with only 11. All right? Questions on how we simplified that? Good. Negative 18 minus 6 over 2 minus 3. Negative 24 over negative 1. What does that simplify to? Positive 24. Thank you, Azalea. That's right. Positive 24. Number 11, we got negative. Oh, did we do this one together yesterday? Yeah, we did, right? All right, I'll just go through it quick. Negative 12 minus negative 9 over negative 17 minus negative 10. So all kinds of double negatives turning into plus signs. I'm going to rewrite this just so I can figure out what on earth is even going on. Negative 12 plus 9 over negative 17 plus 10. Oh, okay, that's just negative 3 over negative 7, which simplifies to positive 3 over 7. And we did that one yesterday, right?
Yeah.
Now, number 12 is really interesting, right? What did you guys get for a slope on number 12? 9 over 2? Thumbs up if you got 9 over 2 for number 12. Beautiful. Now, did anyone do it by putting, like writing out the full slope formula, 9 minus 0 over 2 minus 0?
Yeah.
Right? Good, good. That's perfect. I wanted you to do it in this form. Now, here's the interesting thing. These 2 points form a line, right? Any 2 points in whatever space we're in can form a line if you just connect them, right? What do we call this point, 0, 0?
The origin.
The origin, right? What kind of relationship do we have with a straight line that goes through an origin? What's that relationship called, everybody? Starts with a P? Proportional relationship, right? For us to have a proportional relationship, we need to have a straight line that goes through the origin, right? That's what we learned last week while I was gone and what we reviewed earlier this week. What was the formula for finding K? Again, does anyone remember the formula for finding K?
K equals y over x.
K equals y over x, right? What if we took this point 2, 9 and plugged it into this formula? What will we get for a value of K? 9 over 2, right? Which is exactly the same as our slope. So I mentioned earlier this week that finding K and finding M are really, really similar because they're exactly the same thing, except K only works when our line goes through the origin, okay? With all these other points that we found, well, actually, we don't know if they go through the origin, but this one definitely goes through the origin because it's listed as one of the points, right? So if anyone caught that, awesome. If not, now you know. Go ahead and give this worksheet. If there's any... No, there's no more questions. All right, give this worksheet to whoever's in seat number 1. Yes, Andy. Yeah, go ahead. Give this to whoever's in seat number 1 real quick. I'll come by and get them while you're setting up your notes. Actually, I don't want to do notes just yet.
You're gonna come and collect the box too.
Yeah. Thank you, thank you, thank you.
Thank you, Brazon. What? See what? The blue. You can see it. It's purple. It's purple.
Hold it.
Oh, here, I'll hold it with you. You gotta break this up. Look up.
So go ahead and get your notebooks out real quick, actually, and just to have it prepared. But I want to talk about something else first.
Some dude wasn't even there.
That's okay. Come on in. Go ahead and get your notebook out, Kenny. We're going to talk about one thing real quick, and then we're going to take some notes, okay?
Can I use the bathroom real quick? Because I had to come back on time.
Yeah, go ahead. That's fine.
Oh, hi. Hey, you don't want to
All right. What's going on?
My water bottle accidentally I don't know why
He
water
opened his
bottle.
water bottle and then water spray.
I don't know why he does it.
All right, listen up, guys. So, I want to talk about this in a real life context because a lot of times math, it's really hard to connect to the world around us. But with slope, it's very much a part of our lives. So, we can think of slope as the measure of how steep a line is, right? In our warm-up this morning, we saw one line that was almost completely flat, and then we saw one line that was really, really steep and almost vertical, right? So the one that was steeper had a larger slope of 8, and the one that was more flat had a slope of 1 over 8, right? So this line here we can consider very steep. Has anyone ever heard the term steep before? Good, okay. If you don't know or haven't heard the term steep, something that's steep is just almost vertical, right? If you have a really steep hill or a steep mountain like this, it's going to be really hard to climb up that mountain, right? The more vertical that side of the mountain gets, the harder it is to climb. Everyone see what I'm talking about there?
Uh-huh.
Yep.
I climb up that mountain.
Now this line, in comparison, is not steep at all. It's almost flat, right? It's almost horizontal, just like that second graph we saw in our warm-up. Or the first one was almost flat. So if we put this one on a hill, that one doesn't look as hard to climb up, right? It's not as steep, which makes it look not as scary. Okay? Kenny, go and take a seat. Kenny, stop doing that and take a seat. So, which mountain will require more effort for you to climb? Let's say it's a Saturday, you want to go hiking or something, and you got 2 mountains to pick from. Which of these would you rather climb if you want to conserve your effort? Would you say thumbs up for the mountain on the left, thumbs down for the hill on the right? For which one requires more effort to climb? Thumbs up if you think the mountain has more effort or requires more effort. Thumbs down if you think the hill requires more effort.
Stop trying to be funny, Leslie.
Good, I see lots of thumbs up. That's right. This mountain on the left will require much more effort for us to climb because of how steep it is. Right? How steep is the ground that I'm walking around on right now? Not steep at all, right? I'm putting in like no effort, basically, walking around this classroom. Now, if the floors here were angled like this, I'd probably have a more difficult time walking around, right? So if we have this mountain on the left, it's requiring a high amount of effort. So we're going to see mathematically that we have a large value of m. Like in our warm-up, we had positive 8. But if we have a mountain that requires a low amount of effort to climb, we're going to see mathematically that our slope is small. Okay, it's going to be a fractional slope, 1/2, 1/8, whatever it is, it's going to be small if our line looks kind of flat. Okay? Think about a treadmill for a second. Give me a thumbs up if you've ever been on a treadmill before.
I hate treadmills.
Okay, some people don't like treadmills, that's fine, but a good amount of you have probably been on one or at least been near one before, so you know how it works. Basically, a treadmill just replicates running on a flat surface, right? You can see this guy.
You can put it on incline.
Perfect. You predicted my next slide. Just wait 1 second.
Oh, my
So
bad.
this is a flat treadmill, right? Replicates running on a flat surface. Like I just said, walking on a flat surface, as I've been doing this whole presentation, requires almost 0 effort, right? However, you can change the angle of the treadmill by setting the incline, just like Kenny pointed out. Thank you, Kenny. If you want a more difficult workout. So now we can see that these 2 guys aren't running on a flat ground, right? Or a makeshift flat ground. We've got an angled up, and we've got this treadmill angled up, right? Now, I know it doesn't look as steep as the mountain, but would you say that it's harder to run on a treadmill with an incline than it would be on a flat treadmill?
Yeah.
Yeah, absolutely, right?
Actually, it doesn't feel that much different though.
Right, but this is just an example. It's, obviously you can't, well, let's take a look at, I'll get to it, don't worry.
It's just
So-
like running up.
Yeah, it's like running uphill, but if you run uphill for an hour versus running flat for an hour, you're going to feel it in your quads running uphill, right? So,
I
oops.
couldn't run for an hour either way. That's hard.
I messed this slide up. This is supposed to say incline set at 10. Oops. Okay, well, I explained that. What about this treadmill? Would you be able to run on this treadmill? Would you be able to run on it with your feet flat on the tread
Wait, is
part
that
like a
facing
normal
down or facing
treadmill?
up? No, you cannot
It's
run on
completely vertical.
it. Can't run on that unless you're Spider-Man.
That's right.
Spider-Man.
That's right. You cannot run on this treadmill unless you have gravity-defying powers, right? It would be impossible for me to just walk right up to the board, put my feet on the board, and start walking up the wall.
Anything is possible.
I can try, but I'll break my back.
Can I try Mr. Church?
No, it's okay.
Okay.
So, you wouldn't be able to run on this treadmill, right? It would be impossible. Take a look at the slope of this treadmill. What can we describe that red line as? Horizontal or vertical? Vertical, right? So if our line is completely vertical, we can't exert any effort at all because it would be impossible, right? It's hard to climb uphill as opposed to walking on a flat surface, but it's not even possible to walk on this treadmill. So, here's the takeaways for this, and then we're going to get into notes and you'll see why I'm even talking about this. So with the mountains, we saw that the steeper the slope, the more vertical our line, the more effort's required to climb. But if we're walking on a flat surface like I am right now, it requires almost zero effort, yes?
Yes.
And walking straight upwards into the air is impossible. And we all knew that already, right?
Yes, sir.
So, today's lesson is on zero and undefined slope. Give me a thumbs up if you've ever heard the term undefined in math before. Okay, maybe a couple people undefined? No? All right. That's okay. We're going to learn all about it. So go ahead and get your notes set up just like this. We're going to see why those treadmills are important and what they mean for our math.